Okay, sorry, I don't know what I'm doing. I got disconnected somehow, but we're gonna keep going here. I'm gonna send out this link again to everyone just to make sure we're all on the right video. I think I may have started a new live stream. I don't know what's going on, but luckily I'm connected again, so we're gonna keep going in just a second here. Okay, I think we're all connected here, so I'm just gonna keep going. I see some of you are watching, so I guess that means you found the video, so yay. We're gonna go through just a few more, and then let me know if there's any in particular that you want to see that you think maybe I won't get to because they're at the end. So leave that in the comments because we have a few more, and most likely I'm not going to be able to get to all of them. We'll see. I will post solutions so you can double check your solutions for all of these. But okay, so this next part, we are using the unit circle. We're using it in different ways because what you want to pay attention to here is this part, the function. This is just regular cosine. But if you look here, this is the inverse of sine. This is regular cosine. This is the inverse of tangent. So we have both ways mixed in here. We have to be able to jump back and forth between the inverses and the regular functions. So remember, for regular trig functions, to find sine of any value, on the unit circle, that's the y value. To find cosine of any value, on the unit circle, it's the x value. To find tangent, it's y over x. And then we have its reciprocal. So the reciprocal of sine is cosecant, and that becomes, oops, that should be an arrow, looks kind of weird, 1 over y, or you just flip y. That's really just what it means, flip y. The reciprocal of cosine is secant, and so we have 1 over x, or just flip your x. Cotangent is x over y. Again, you flip your tangent, or it could just be easier to do x over y. And remember, both of these, like y over x, is the same thing as y times the reciprocal of x. And x over y is the same thing as x times the reciprocal of y. So sometimes it's easier to think of it in terms of multiplication instead of division, because that's what you end up doing anyways when you have these fractions that you're getting from the unit circle. So this is some key information for solving these problems here. So this is saying, what is cosine of 45 degrees? Well, to find cosine of 45 degrees, we need to look at the x value at 45 degrees on the unit circle. 45 degrees lands in the first quadrant, right there in the middle. So this is 45 degrees. The point at that angle is root 2 over 2, comma root 2 over 2. So we need to look at the x-coordinate. The x-coordinate is root 2 over 2. So that is our answer for number 16, root 2 over 2. I'm going to write that on the side here. We just need to know what is the cosine of 45 degrees. 17 is asking us what is the inverse sine of negative root 3 over 2. So we still need to think about what is sine, which coordinate is it, and we see that sine is the y coordinate. But what this is telling us is we need to look to see what angle is sine going to be a y coordinate of negative root 3 over 2. So we can look at the unit circle. I'm going to try and open up the unit circle. Hopefully I don't get locked out here again. Let's see. Okay. Oh, cool. We're still connected. All right. So I need to look to the unit circle here. And for sine and, not cosine, sine and tangent, we're only going to look at the right side of the unit circle, so just in these quadrants 1 and 4, and I'm looking for any y values of negative root 3 over 2. Well, I know that in this first quadrant, they're all positive values, both x and y are positive, so I'm going to have to come down to this fourth quadrant to find my answer. And I see that at 5 pi over 3, there is a y value of negative root 3 over 2. So that is going to be my solution because sine is y. So we have a y value of negative root 3 over 2 right at 5 pi over 3. So that is